Good afternoon, everyone. So I'm Rachel Reese. This is Patterns and Practices for Real-World Event-Driven Microservices. How many of you folks actually are using microservices right now? Oh, good crowd. Okay, excellent, yay. That is more, I think, than any other crowd I've given this talk to. This is awesome. So I was going to start by sort of defining what each of these pieces mean, the real world, the event-driven, and microservices. So we'll start with real world. I work for a company called Jet.com. We only ship to the US for right now, so I'm sorry. But we are taking on Amazon. We're a startup. We launched on, I don't have that anymore, July 22nd. And we built our entire infrastructure around microservices. So we have 300, maybe 350 microservices by now. But just to show you guys what I mean by real world, we have almost 20,000 orders per day. And when I first created this slide in maybe August, about a month after we launched, that number was more like 2,500. So we've grown from 2,500 orders a day in August to 20,000 orders a day last week. Over 7 million SKUs on the site, so a fair amount of products. 600,000 first-time buyers, 500,000 mobile downloads. So there is fairly heavy traffic on our site. We have been featured in the App Store and the Android Store, so that's part of where this 500,000 mobile downloads is coming from. But like I said, there is a need for an infrastructure that can handle that kind of load. This is some of the technologies we use. You can see that they're grouped a little bit. We have Azure technologies on the top, F# technologies in the middle. This section right here, some of our data science, React, Node, and Angular, our front end. And then the green, can you guys read the green at the back? Okay, I will actually just read them to you. Storm, Elasticsearch, Event Store, Microservices, Console, Kafka, Apache Tez, Apache Hive, Jenkins, Puppet, SQL, Redis, and Splunk. And that's our other category. And I have the same slide in my talk for tomorrow, so I will update that. But just so you get an idea that we are sort of all over the place. We use whatever technology is right for the job. We are heavy users, obviously, of F# and Azure, but we don't limit ourselves to anything specific. So microservices. To us, that means an application of the single responsibility at the service level. So just, and if you don't know what the single responsibility principle is, a class should have one and only one reason to change. So the microservice should have one and only one reason to act. It doesn't have to be as simple as, actually only one function. I've heard people say that. But it should have only one function in the concept. It should only have one reason to do the thing, one reason to exist. It should do one thing. And specifically, it should have an input and produce an output. So these two things are sort of what define microservices to us. And the benefits of that, if you're new to microservices, very easy scalability. I mean, it's very simple to update a single microservice, scale that out, and make this one task that it's doing, go further and have that much, expand it and scale. There's also independent releasability. Like I said, there's also a more even, I think, distribution of complexity. So it's easier to create and maintain services. So there's a very small amount of logic. You can, one team can be responsible for 5 or 10 different services very easily. But it does tend to be harder to manage all of the services. So you're shifting the complexity from business logic onto the infrastructure. I still think that it's way better than one giant monolithic solution with 25 different projects, because I have coded in giant monolithic solutions with 25 projects, and it can be a nightmare. So it is just a switching of complexity, but I would say definitely for a good reason. Now, event-driven. Are any of you doing event-driven, or I will talk about also event sourcing currently? Excellent. So event-driven, specifically, just means the focus of your application code is to react to events. It can be a single event, this one little dot. It can be an entire stream of events. But the focus is just to respond to that event. An event being any significant change in state that's happened. So specifically, if you guys have seen Greg Young's talks, that should be past tense. It should be immutable. It should be something that has already happened. The customer has relocated. The cargo has shipped. The shopping cart purchase has been made. But it also, an event can refer both to the event itself as well as a notification system that tells the rest of the system that the event has happened. So if we're thinking about events as a notification message, there's this event emitter is saying, hey, this event has happened, hey, this event has happened. And each of these gray dots here basically is a message saying an event has happened. They'll travel through the event channel, get over to the event consumer, and the event consumer consumes these events consumes these event messages knowing that an event has happened. This is basically push-based notification. Does anyone here use RX? Anything reactively? Ooh, a lower crowd. So the reactive manifesto it talks about four concepts for modern reactive applications. Should be responsive, they should be message-driven, should be resilient, and elastic. And microservices very much fall under that. If you're using RX, specifically, you can treat a microservice input just actually as an observable. So think about how event-driven is reactive. If you're treating events as an observables, the microservices are just an observable. And specifically, since they're observable, you can event source them. And event sourcing is slightly different than event-driven. Event sourcing is more about how you model the domain. So it's, rather than having your standard relational database, you're looking at an append-only sequence of events as your data store. So you keep track of all the state changes, all of those, cargo has shipped, customer has relocated, all of those past tense things that have happened. And then you can replay these event streams. So you can replay the entire life cycle of, when your customer relocated, or all the different places customer has lived, all of the different shopping carts customer has had. This is different than your standard relational model, where we're looking at everything that has actually happened, rather than only the latest state change and only the current state only the current place that the customer lives, or only the current shopping cart. We're not looking at those things. We're keeping an entire history of everything that has happened. It's a lot like, your standard account history or ledger. You can, see all of these things, all of the posts that have been made to an account. If something gets messed up, your bank isn't going to just delete that post. It's going to make a new post that updates, and maybe takes the money away from you. There was a bank error in your favor, then you get that money taken out. So you can go back through and replay all of these. Say you wanted to suddenly have a time included in the date field. If you captured that information originally, but you're just not displaying it here, you can go through and change all of that, replay all of these events, and add in that piece of information so that you now have that later. Say if you found a bug, you need to change your SQL schema and add a completely new field. You can replay an entire stream of events and add a new piece of information in, so that you don't have an entirely null column, or you have to work around that null column. Say you're reindexing Elasticsearch. I actually have one of my coworkers needed to rerun his entire service because he actually ran out of sockets that he was working on. He's like, that's a pretty special case. Don't talk about that one. But all of these things you would need to do to replay all these streams. So do these concepts make sense to everyone? I feel like a lot of you folks are actually working with event sourcing already and working with microservices. So I glazed over that a little bit. Awesome. So much slower now. Guidelines. Like I said, we have about 350 microservices that we're currently working with. And these are the lessons we have learned along our way. Very specifically, and first, don't abstract. We could have one magical service that could, write to event store, write to MSMQ, write to 0MQ. It could do all of these wonderful things, and it will do them badly. Because if you're trying to abstract to do all of these very specific things, you're going to abstract in a way that doesn't take advantage of special features that each one of these technologies has. And there are good places to abstract and there are bad places to abstract. And if you're abstracting away a useful feature of a technology that is, special, say, to only 0MQ, then you're losing the ability to actually use that special feature that's available to 0MQ. And write a special microservice. These are microservices. They are tiny for a reason. You can have 5 of them to write to each one of these places. It's easy. It makes sense. This is something we did to begin with. Developers always want to abstract as much as they can and take things to a higher level. And wouldn't it just be beautiful if you had one magic thing? No, it wouldn't. I promise. It's also very important to be functional. Like I said, we work a lot with F#. We have almost 65 developers, and our backend is basically exclusively F#. We have a few other things on the front end, but the vast majority of our code is written in F#. And that helps us a ton. What functional specifically means to us, using data in, data out transformations. Like I said, a microservice has an input, has an output. Think about what your inputs will be. Think about what your outputs will be. Think about what that transformation is in the middle. Think about how that map will happen. Look at problems recursively. So, consider slightly smaller chunks of a problem. Recursion is a very natural thing to do once you're working with functional programming. But specifically, if you're thinking about what the inputs and outputs are already, then thinking about how to create successively smaller chunks of each problem is going to be a lot easier. Also, treating functions as the unit of work, working with higher order functions. You can have one microservice that, say, applies a template or, applies some sort of map function. And you can send that function in as a parameter to your microservice. And that's, think about functions and not objects as your unit of work. Also, preferring immutability. And this is almost the most fundamental one. But all of these work with each other. If you're preferring immutability, if you're avoiding state changes and side effects as much as you can, then you'll be working with mapping inputs and outputs and data in, data out transformations. Once you have your input and then you're mapping that and you have an output, there is nothing really that's mutable in there anyway. So I have often found a lot of people will try to implement one portion of the, move one small step at a time, and that's actually a lot harder. Because if you start with something, like immutability, it ends up being, like I've said, natural to just follow through with these next 3 things. They all very much work together. And specifically, we use F#. This is the new F# logo up in the corner. So yay, F#. And I will have a little bit of F#. How many of you folks actually have worked with F#? Awesome. I will have a little bit of code that I will show you guys at the end. But also, next up, isolate side effects. If you have, sticking with the try to not have anything that is mutable and avoiding state changes, there are some state changes you will need to have that just happens. You need to log to figure out what's going on. You'll need to do things like sending a thank you email. That happens. That is the way the web works. But if you have a submit order microservice, for example, that updates SQL with your latest, the latest state has happened, and then it sends a thank you for ordering email, don't do this. This is awful. This is terrible. At some point, you will want to rerun all of these events that come up that this microservice works off of, and it will update the SQL, and it will resend all of those thank you emails for you for 6 months of customers who are suddenly getting a thank you for ordering email for something they ordered 4 months ago. And that's really awkward. This did not happen to us in production, but it did almost happen. So separate these two. It's a very, it seems obvious when you see something like this. Create one order to send one microservice to send the SQL order. Create a separate microservice that actually sends the thank you email. At that point, you've isolated the thank you email microservice. You can replay the insert order if you needed to update your SQL schema, for example. Then you can update that. It won't affect the email. The customers aren't going to know that you're reworking something from 4 months ago. And you've fixed this bug now. So just when you do need to have side effects, make sure they're isolated. Also, use a backup service. This is something that we discovered, another thing that seemed obvious in hindsight. Have a service one, whatever it is, again, if it's your submitted order service, have that run in production, perfectly fine, everything's cool, it's going on. Have a backup service that you have in, on a separate machine or a separate VM that replays all of the events until it gets up to date. Maybe this fixes a code, a bug, something that's wrong. Replays all these events until it gets up to date, and then switch over to that microservice, do a live transfer, and you're up to date and ready to go with that one. Also make sure, very importantly, that you are staging a copy of any data store that is associated with that microservice. That way it can update and manipulate the data store that it needs, and you switch both of those over when you're ready to go live, and you can keep the other one for a future backup. But this means that it might take an hour or whatever to replay all of these events, get everything sorted and switched over, and the new piece of information up and ready to go. And at that point, you have your data store, it's working, you have your new service, you know it's working. It was basically done in a staging environment. So if something does go wrong, you can stop it, start over, until you get this quite right, and then, again, live switch over, and you're good to go. So here's the F# that I promised you. What our services actually look like. We found that it was very important to have a standard format for each one of our services. And this is my my service that basically takes it does a price check on some magical Nile website. You guys should all laugh now. It's hilarious. I'm sorry. But specifically, you want to start with looking at the inputs and the outputs. Here, we're doing a price check, so we have a product that comes in. And then at the end, we have the output is either a product with the new price check on this magical Nile website, or the price check failed. We couldn't find that product. It was priced totally strangely. Something was weird. The data was inconsistent. Something there failed. So we have the two types of possible outputs and the one specific product input. Then determine, once you have your inputs and outputs and you're settled there, look at how to transform the input to the output. Like I mentioned, that's, think about your transformations. Think about how the input should transform into the output. We do that here. It isn't necessarily always called handle, but this is how the input should be handled. And in this case, I am just returning a brand new product that happens to have here a decimal of price, associated with it. But this would obviously be the code where you would actually go out and maybe scrape the site or hook into an API somehow and figure out what that actual product SKU would be. So this is the meat, really, of the microservice. And especially with something like this, that code isn't necessarily small. There can be a lot going on, but the point of this microservice is to, one thing, you have a product, you need to find the price on that product. Next, figure out what to do with the output. Once you have an output, what is happening here? Here we're doing some pattern matching. If the output on this first line, if we actually received an output in the top one, there's a product, there is a price associated with it, everything went totally fine, then, for example, we might want to write to event store. I didn't include this code here so that it all would fit, but you would want to do something like this, write to event store, further process that, send it off to another microservice, potentially. Do something with that successful bit of code. The other thing that might happen, you have an output, and the product price checked failed. So in that case, you might want to log a failure. You might try it again if you have some idea. Might send it off to an error microservice that handles some of these options. So it might know that in these sorts of, these 4 certain specific types of failures, you need to look at, you want to check something specific and try again. So there are lots of different things. It doesn't have to be just a logging failure sort of thing that is how this would work. In the case where, so sum is sort of like a nullable in C#, the sum and none at the beginning. That will basically determine whether or not there is actually a response. So in the first 2 cases, there is a response. The first case, there is a response, and it is a success response. In the second case, there is a response, and it was a failure response. In the last case, there is no response. Maybe the website was down. Maybe some sort of intermediate, something failed miserably, and we don't know what's happening. So here you probably actually wouldn't want an async return. You might want to, again, log or somehow try, maybe try again in 5 minutes. But again, there are the 3 cases here, the success case, the failure case, and the, oh my God, everything failed case. But once you figure out, what to do with that output, what that actually means that you've gotten one of these kinds of outputs, then the last section we have right here is how to read the events, handle so we're sort of starting over. This is the section here. We're basically consuming a specific stream of events. We're sending in the product type to begin with, which we do with that bit of code, this decode T. And so we're basically saying, figure out what this, grab that product, consume that from an event store, and then we're sending in both this handle function up here and the interpret function to basically say, now run this microservice, start everything up and go. And if something happens, again, if something additionally happens here, we have this catch and log everything additional. So one more concept here, the pipeline, since many folks here have not worked with F#, the pipe at the bottom, which is these 2 characters, the actual pipe and the greater than sign, that works a lot like Unix shell scripting. If you have done that, it is the same pipe concept, or PowerShell, I know, also has the same pipe concept. It basically takes the output of the previous line and sends that in as a parameter for the next line. So we're able to take this event store queue consume line and say, if something goes wrong in that, take whatever the output is to that, and log it if there is an event, if there is an error. But specifically, being functional allows us to have, and there's several other ways that we can handle this composition, but often in microservices, we will have several different pipes. We might log something to start and come down and then run a bit of our code, log something else, maybe check for something, but we can all do this very compositionally, very functionally, using this pipeline structure. It ends up being absolutely crucial to the readability of our services, readability often of our code in general, but very specifically our services, because it is easy to see, this is the item that we're starting with, and these are the steps that it takes through the process. You're going to log something, you're going to check for something else, you're going to do this next thing, and then come down here. And sometimes there are 6, 7, 8 different steps in there, and having that pipeline structure makes it very obvious what is happening. Also, very important, microservices should not control their own lifecycle. Not lifestyle, that is a very different thing. If you think about what I said at the beginning about that it shifts the complexity from the code onto the infrastructure. here is the infrastructure. This is the part that you really need to talk about, to think about, to make sure is very important, is done correctly and is important. And this is the part that is the hardest, I would say, and the part that has the most chances of really being messed up. But so if you're going to do microservices, I would recommend a product, any product. People use Docker, people use Console for these top thing, execution runtime, for deployment, for availability, for discovery. All of these things, there are programs that will do. We ended up rolling our own because we thought we're awesome. But for a couple reasons. One, because we're using Azure, and it often is a little more difficult. It can take a long time, to restart a service, to get up and do all these things. We rolled our own product, which we called Torch. At Jet, everything is named after superheroes. So there's the superhero Torch. It is not, a flashlight. But we're able to push out a new microservice, push out a brand new build in about 30 seconds with Torch, rather than about 15 to 20 minutes with doing everything by hand or using any of these other tools. We also eventually really wanted to build in the ability, and we're working on this right now, but it's not quite done, but the ability to, as part of scaling, scale out entire VMs with associated services. So if there's, my price check for Nile, if that service is related to a price check for, other websites that I don't have such clever names for, then maybe you can scale all of those at once. Scale 8 different services all on one machine as a VM, and scale that, put in 3 or 4 different of that VM, and do that automatically, just as needed. So the top 4 things are what our Torch product currently does. The bottom 3 are what we are working on right now, in addition to being able to scale out as part of a VM. But specifically, think about inversion of control. So you don't want the microservice to know anything about its own lifecycle. You want these other products up here to be able to manage all of that and handle all of that for it. Excuse me. So we do this with, first of all, here is Torch. Yay, Torch. We do this using a lot of YAML files. There's 1 per microservice. And they're very simple. You have a version, what version of Torch we're on, what the subsystem is. So we can group these, as we were talking about scaling a VM, you can group these into a subsystem that might be the 5 different things that are scaled in one specific VM. What the name is, a description, a version of the microservice itself, whether or not to auto start the service, whether or not you want to compile the service on the VM, once it gets started. The AA stands for active-active, and it could be AP for active-passive. Active-active basically says that there are 2 nodes that are going, and they're both active. You could fail over to one at a moment's notice, but it's up and it's live and it's ready to go. Active-passive is not live, but is you could fail over it. It will take a lot more time to get it up and ready. It's only brought online when it needs to when you need to actually fail over to it. But the really fun thing here, I went to look up to make sure I actually knew what YAML stood for. It means YAML ain't markup language, which is fun because recursive acronyms have always made me smile. They're fun. But it used to mean yet another markup language and was backronymed. So they changed the meaning of it, and I didn't know backronymed was a thing, and apparently it is. So they changed the meaning to mean the exact opposite thing. It's not yet another markup language, but now it's not markup language. And they specifically wanted to clarify it at, it's not like ML or any of these other markup languages. It's specifically data oriented. So that made me really happy. But the summary, so I should have spoken a lot slower. Again, don't abstract. It's very important to not build The point of microservices is that they are microservices. They are small. They are supposed to be, single responsibility principle, maybe not single use, but single responsibility principle services. Don't try to make them fit 10 different pieces. These should be small, focused pieces of technology. Second, be functional, and that has helped us so much. Having F#, having the ability to pipe and and compose everything through. It also, some of the other features of F#, it is generally, it's an easier language to look at it because of the type inference, because of the lack of curly braces, because of it is white space sensitive. It eliminates a lot of this cruft that people will call it of programming. So there's a lot less to look at on a page, and especially the sum and the none, the nullable like structure that I was talking about. That is technically what is called a discriminated union. And a discriminated union, which was actually, if we come back here, the inputs and outputs are discriminated unions. The way these work is, it's a couple different types all sort of combined into one. And you can use for example, an object hierarchy can be modeled like this. You have a very standard base class, maybe 3 classes that inherit from it. You can model that, the base class would be output, and then any classes that inherit from it would be the next lines. So unlike C#, where you might need 3 or 4 separate files to contain all this information and contain, what objects are actually in there, what properties they have. In F# you need one line, product price nil of product star decimal, and product star decimal are the property that it has. So there's a product in there, and there's a price type in there. And that's it. You can have that all on 3 here separate lines. But specifically, being able to use something like a discriminated union makes our code a lot shorter. There's, like I said, rather than having 4 or 5 or 30 different files to model an entire domain, we have one file and 30 or 40 different lines within it. And it makes it a lot easier for people coming up to speed, to see what's going on, to look at everything. It makes it just very clear what is happening. Some of you may have heard stories about how, F# has no bugs. And of course there are bugs, but it's a lot easier when it is a lot easier to see what's going on, you just do make fewer mistakes. So even the developers that we hire on, who some have literally never even seen F# before, are usually up and running somewhat quickly because it is easier to see the code. The code is it's reduced. There's only the necessary pieces sitting out there. Specifically also isolate the side effects. If you have a microservice that has a side effect associated with it, make sure that is the only thing that the microservice does. There shouldn't be 3 different side effects or 2, one thing that's happening like writing to SQL Server or reindexing Elasticsearch. There shouldn't be anything like that combined with something that is specifically a side effect. The side effect is something you guys probably know, but excuse me, like writing to a log, something that changes the state of something that is out there. Writing to a database or sending this email or something that affects the outside world. Make sure you're using a backup service, and this is something that we implemented on one project. Realized that this is genius, this is perfect, we have to be doing this. And we went back and implemented it on many other projects. But just basically the idea of having a service running in production that you can rerun your entire event store through this service, catch it up on whatever the latest version is, and then switch over to that live. It's a much easier way of to switch everything. You know, they're not tinkering with anything actually in production yet. You're just rerunning the service. And then use consistent formatting. It makes it, in a company with almost 350 microservices, again, this makes it very easy for somebody who is new to the team to come in and look for, these are the inputs, these are the outputs, these are how they are handled. This is how, that result should be interpreted. This is, how the microservice itself is consumed. This is how you start everything. Just knowing that those pieces need to be there wherever it is that they are, whatever the service does, excuse me again, that ends up being a lot easier to bring somebody up to speed. It also tends to keep things functional. So again, because we're using consistent formatting, because we have this a function that will handle the events, we have a function that will interpret the events, and we're sending those in as parameters into the final function that actually runs everything. Because we're doing, we can change how that all works, and it's just a parameter into the final function. It's a lot easier to work that way, to understand how all of this flows. And finally, using an outside product to control the lifecycle. So like I said, we rolled our own. There's a lot of very interesting things that we are doing with Torch, but whether you use console or Docker or something, it is very, very important to have some product that handles the infrastructure around microservices. This is something that I would say needs to be thought of sort of upfront. I watched a presentation, and I forget who. I would love to be able to quote them specifically by name. Very recently on microservices anti-patterns, and one of the anti-patterns they had said was people who specifically start with microservices. Start with all your basic, start with a monolithic application as you need, and then tear out small pieces and make them into a microservice. Have one piece over here that does one thing, one piece over here. And that is great advice, but the only thing I would add to that is make sure you have an infrastructure in place to begin. Like, that is something that needs to be thought of as part of the fact that we might be moving to microservices, and let's consider pulling out this first piece. Just because that microservice, that infrastructure is so important, and really, like we've said, is where all of the complexity lies. Yeah, so I'm done a smidge early, but are there any questions? Yes. I know that some of the teams, so I've worked on 2 of the teams and not the rest of the teams at my company, and I know that some of them do, but the ones I was on did not. So I don't know I don't know if they're exactly comparable, but no, I don't know what the benefits are or the. That is mostly done with Torch. And yes. Sure. Anybody else? All right, feel free to come and talk to me afterwards. Thank you guys very much.